Hi all, this is Rehan from Global Tourism Management. Me and my team members, including Charles, Piyush, Rob, Summer, Yaya, going to present on climate change for Royal Roads University. Climate change could be one of the major factor impacting tourism in long run and has various element in this presentation has been considered and suggested to take to overcome the situation in the BC region. Historical data, average annual temperature 1.54% has been increased. The nighttime minimum average temperature in winter 3.1 degrees Celsius has been increased. Annual precipitation has been increased, average sea level has been increased, lakes and river becoming more free of ice earlier than in the spring, water in the Fraser River is warmer in summer. By 2050, we are expecting what we have studied and analyzed like temperature between 1 to 3 to 2.7% increase, growing seasons that are longer though hampered by more frequent and severe drought, shifting infectious diseases and pests with effects to our health, agriculture and ecosystems. More frequent and severe heat waves resulting is increase in heat related illnesses. The next slide talk about the sea levels increase globally and also in what we have encountered in BC region. By 2100, the highest we can see here is 2.0 meter and intermediate would be between 1.2 meter. And this is based on our scenario and our studies, which my team is going to go and explain into a deep detail about it. There could be a more flooding, straining drainage and sewage system problem, intruding into groundwater aquifers, low-lying agricultural land becoming too saline for cultivation. This is what we have seen, like 6.6 centimeter per century at Victoria climate model project of future rise mean sea level to 26 to 98 centimeter by 2100. Precipitation indicators, snowpacks refer to the depth of snow on the ground, the daily depth average over the season. So there are two scenarios which we have captured here. It's CRD as per the CRD website, like snowpack in the past in 1971 to 2000, and then in future the predicted one is between 2040 to 2070. Snowpack is projected to decrease significantly over time because of the climate change, with an average winter snowpack depth measuring 15 centimeter. Projection indicates a 91% decrease in April by snowpack by 2050 for the same. So we have considered all this scenario in the same time frame for all the factors related to climate. Glaciers are melting. By 2018 to 2100, up to 70% of glaciers may have disappeared. As you see in the picture, by 2100 expected to result in changes in the river flow, temperature affecting fish habitat and hydroelectricity, power generation, drinking water decreases in quality and quantity wise, water shortages increase in competition between various water users. Climate change and health, this is one of the important factor which is also impacting health as I can explain in this scenario. Climate change and impact of health related thing is also explained in this slide. Climate change is likely to, on the left hand side is illustrated. Climate change is likely to impact most areas of our lives, including our health. In British Columbia, the principal hazards including rise temperatures, sea levels rise, and increased frequency and intensity of the extreme weather events. So population and community health are influenced by wider social, cultural, economic, and environmental factors. These factors are commonly known as health determinants and they are closely linked to range of health outcomes. Increasing climate change hazards are impacting health determinants as illustrated in this figure. This impact in turn influence and affect physical and mental health outcomes. The challenges are like storm surges, temporary flooding, stress, anxiety and trauma, food and water contaminations, and
Okay, hi, I'm Summer. Now I'm gonna talk about the factors of uncertainty in Victoria. The factors include those ones that are most difficult to project for the future, like magnitude, timing, and distribution of climate impacts, the changes in Victoria's communities, economy, and environment, and the population demographics and changes in the structure of the economy. And also, I'm going to talk about the vulnerability. The vulnerability in order to analysis the climate change impacts. Both vulnerability and risk are evaluated, and according to a report, vulnerability is a function of both a community's exposure or susceptibility to harm and its capacity to respond and thereby adapt to a changing climate. So we have a function over here. We have the vulnerability equals sensitivity minus resiliency. And also vulnerability can be expressed in terms of the weather events that expose the greatest vulnerability, like the sea level rise, and also storm, and those ones that we're gonna explore in the next slide. And also those impacts to which Victoria is most vulnerable, and we're gonna discuss about the surface areas that are most vulnerable. So we have analysis of both the sensitivity and the resilience of each of the surface areas to the projected climate change events identified for Victoria were completed. And we have the results over here. First, we have the climate events that's gonna impose the most vulnerability for Victoria to the climate change. We have the increase in sea level over here. As you can see, increased sea level, they all reach the medium and high vulnerability score. And also we can see the increased frequency and severity of extreme weather events. The first 5 bars are at the among the range between medium and high. And we have the reason why sea level have increased vulnerability for Victoria, because access to seawall piers and docks and other coastal infrastructure and surfaces may be restricted due to the flooding and damage. And also for the weather events, the extreme weather events like storms, because the inflow and infiltration will cause sections of sewer system to exceed capacity. Sewage will backflows into homes and discharge from outfalls untreated. That will be total disaster for Victoria homes. And also we have another graph. This graph shows about the surface areas with greatest vulnerability. We have 13 types of them here, but we can see the first 6 of them are with the most vulnerability. So we have mobility and transportation, and the second one is buildings, and the third is emergency management. The fourth one is land management, and the fifth one is parks and natural environment. And the last one is underground utilities. So those are the most vulnerable ones, and because it's the with the highest with is sensitive to sea level rise, but relatively low resiliency due to the high replacement cost of the infrastructure. So overall, we think high vulnerability scores show high sensitivity and low resiliency, indicating that the impacts risk needs to be well understood. And now Yaya is going to talk about the complexity of climate change in Victoria, and let's welcome Yaya.
Hi, I'm Yaya. I will talk about the complexity of climate change in Victoria. So first, we have to figure out what caused the climate change. The primary reason for the climate change appears to be increase in greenhouse gases in the atmosphere. Greenhouse gases include water vapor, carbon dioxide, methane, nitrous oxide, ozone, and halocarbons. These gases, especially water vapor, carbon dioxide, and methane, trap heat in the atmosphere. As their concentration in the atmosphere increases, so does the heat trapping capacity of the atmosphere and thus the temperature of the Earth. There are natural sources of these gases, such as volcanoes, marshes, and animal respiration. However, an increasing amount of greenhouse gas comes from human activities. Burning of fossil fuels, such as coal and oil, release carbon dioxide in large amounts. Growing rice, raising livestock, and dumping garbage in landfills produce large amounts of the methane, and nitrogen-based fertilizers used on our crops release nitrous oxide. It can be seen from the picture that the factors which can cause climate change are diverse. So they also lead to lots of impacts, which my partner will mention later. As for Victoria, the main cause of climate change is human activity, followed by the natural factors. So for the human activities, Victoria's carbon footprint stems largely from the energy used to heat buildings and the fuels that propel vehicles, and what becomes of waste after it is discarded. In 2017, of the 370,000 tons of greenhouse gases emitted, approximately 50% of Victoria's greenhouse gases emissions came from buildings, and 40% came from the transportation, and 10% from the waste. Building-related greenhouse gas emissions thus come primarily from combustion of heating oil and natural gas. The transportation sector produces greenhouse gases mainly by burning gasoline, diesel, and propane fuels in passenger vehicles. Regionally, emissions from municipal waste come from methane released by decomposition of organic waste at the Harlan landfill. Methane is a powerful greenhouse gas which traps heat in Earth's atmosphere more effectively than CO2. And for the natural factors, Victoria located in the British Columbia, and which is the most physical and biological diverse region in Canada. Natural resources Canada shows that they influence British Columbia's climate and ecosystems. Variability in British Columbia's climate is responsive to changes in the intensity of these oceanic pressure systems, which in turn are associated with changing ocean temperatures and currents. As such, variability in most of British Columbia's climate is connected to a large-scale ocean atmospheric phenomenon, namely the El Niño Southern Oscillation and the Pacific Decadal Oscillation. In addition to the impact of the ocean, the Victorian region may also face local disturbances, such as the wildfire, the insects, the disease, and wind through. So, in Victoria, although climate change is blamed on forest fires, devastating floods, and glacial shrinkage, scientists believe that the severity of climate change depends more on the extent of greenhouse gas emissions from the human activities. Now, pass this to Rob.
So we're going to be talking about scenarios. The scenarios that we came up with for the drivers, we use environment and infrastructure. We chose these because the environment is a positive or negative impact on weather due to climate change for the Victoria region. And infrastructure, we defined it as the readiness of Victoria to handle dramatic environmental events due to the climate change. Example, forest fires or extreme storms, floods or droughts. So our first scenario that we came up with was a low investment in infrastructure with a positive events with climate change, and we call this calculated risk. This is when Victoria has not invested in infrastructure that can minimize the impact of climate change, which means events like forest fire or extreme storms could impact guest experience in the city. As a result, Victoria has gambled on the future of tourism in the area. Despite this risk, climate change impact seems to be minimal, where tourism continues to operate as it currently is. Although a lack of improvement in tourism infrastructure negates any ability for the city to capitalize on any of the potential benefits of climate change. The tourism market is healthy in this scenario, but it does not have any ability to adapt to any climate change events or grow beyond its current state. Our next scenario that we came up with was a positive environmental factors and a large increase in investment in infrastructure, and that was what we called positive and ready. Now, Victoria has invested heavily into tourism and infrastructure in this scenario, and climate change seems to be providing a positive gain to the region. with longer, warmer summers are providing a longer, busier tourism season for the city. Improved infrastructure allows the city to maintain guest experience even in the case of weather events. Now, its ability to respond to potential flood or fire allows the city to capitalize on increase in tourism in a safe and profitable manner, and tourism booms as a result. Jobs are created and new opportunities arise. Confidence in Victoria's ability to adapt and overcome climate change increases investment in the city overall. Now, for some of the negative effects, we called Victoria unprepared, and this was low investment in infrastructure and extreme weather events. This is when Victoria has not invested in infrastructure that designed to reduce the impact of climate change. Events such as forest fires, floods, and extended droughts are negatively impacting the tourism industry in Victoria. The city and businesses are forced to endure high costs of repairs during extreme weather events. As a result, businesses are forced to cut costs and reduce staff. Without the ability for the city to adapt to climate change, the tourism industry begins to decline. Local businesses close and guest satisfaction is negatively impacted. Our last scenario was prepared for the worst, which is a high investment in infrastructure, but a very negative effects from climate change. And that is when the city's ability to manage droughts, floods, and allows tourism to continue. With investment in the industry, local businesses can find new opportunities in the market with an extended summer and season, but still be able to respond to some of those negative effects from climate. Despite the negative effects, Victoria's tourism industry sees a growth leading to job creation. Our next slide is one of our potential scenarios in which we compared precipitation and the average temperatures for the months of July and August. We found that Victoria on the low end of precipitation, somewhere in the middle, and about the next 30 years would resemble an area similar to Seattle, with average temperatures for the months of July and August being as high as 22.2 degrees or 22.8 degrees respectively, similar to the lowest levels of predicted temperature change for Victoria. Average precipitation for the year is 866 millimeters. Victoria's current average is 841 millimeters. And with being on the low end of the predictions for rainfall for Victoria, we're expecting it to be about 860 millimeters. Beaches and parks may see a rise in summer tourism due to longer, drier summer seasons. The Seattle scenario is what we call best case scenarios. It's similar to Victoria and Vancouver Island as far as ecology and environment. And we can already see that it's an existing city and it's already dealing with this existing environment. And Victoria and Seattle are both categorized as sub-Mediterranean climates. I'll now pass it off to Charles.
So for the worst case scenario is Portland. Portland has a high of 27 centigrade and 27.3 centigrade in the month of July and August respectively. So also, Portland's yearly average temperature is only 12.45 centigrade, which would be similar to Victoria's yearly average of 9.7 centigrade plus 1.5 centigrade increase. However, the current precipitation levels of 914 millimeters are in line with an 8% increase predicted at the high end of the Victoria at 908 millimeters. Portland is a mix of Mediterranean and oceanic climates under the Köppen classification. In this scenario, it will be inferred that Victoria's climate will be shifting out of the sub-Mediterranean zone.
Hi, good afternoon, everybody. My name is Piyush, and I'll be talking about adaptive capacity. Adaptive capacity, in simple words, means coping capacity. It decreases vulnerability and increases resilience. And so, adaptive capacity in context with climate change refers to the potential capability or ability of an ecosystem or a community to adapt to climate change stimuli. By increasing adaptive capacity, vulnerability to climate change and future climate are reduced. A very key important factor for adaptation is infrastructure for coastal flood management system. The leaders at the coast have to plan ahead and take long-term steps in infrastructure planning for the communities to adapt to sea level rise. One of the action points to be included in the periodic community plans should be to increase the flood construction level. Invest in retreats. Communities should invest in funds to purchase waterfront properties for recreational purposes, which will reduce the consequence of flooding. A good example is Campbell River on the east coast of Vancouver Island. Both public and private sectors should consider sea level rise in planning to reduce costs later. With the sea level rise, existing buildings and neighbors have to be resilient. And so, to help mitigate the future damage, the houses have to be built on a higher elevated structure. Green Shore, or beach nourishment as they're called, promotes sustainable use of shoreline ecosystems through education, planning, and designing that recognizes the ecological features and provides recreational values. Dikes are always sensitive for aquatic habitat. Without dikes, wetlands will move upslope in the response to sea level rise. Therefore, raised dikes will be the part of adapting to climate change. Innovation in urban design. Buildings constructed today will have to anticipate flood levels and their end of lifespan, which may be 50 to 100 years from now. The next important factor for climate change adaptation is partnerships for coastal flood management, and working in coordinated partnerships with communities, government agencies, and various industries and institutions for future can reduce impact of climate change, and minimize the risk of future sea level rise. A future flood plan map should be drawn up in order to establish what assets are at risk, and the managers of those assets should then partner to fund for adaptation. Sea level rise partners should also look at involving insurance companies to introduce residential flood insurance for residencies. In Victoria, there's ample opportunity to partner with parks for green shore adaptation, to manage flood-prone areas for nature conservation and public enjoyment between flood events. Widened shoreline trails can reserve space for future sea level rise. The next factor is infrastructure for rainfall water management. In British Columbia, climate change is expected to bring more intense short-duration storms and increased runoff from roof and pavement. And therefore, to adapt to climate change, we need to increase the use of green infrastructure across urbanizing watersheds. Furthermore, we need to incorporate green infrastructure at the time of reconstruction of urban development of parking streets. Rain gardens will help resiliency within the city storm water system, which will further improve water quality system and make the city attractive. A climate change creates summer drought conditions and water price rises. Rainforest harvesting reuse will increase. Bringing us to that knowledge and skills are another very key important factor for adaptation towards climate change. As climate change affects multiple sectors at multiple levels, the ability to generate and use knowledge is one of the most important indicators of adaptive capacity. Preparing systems to successfully adapt to climate change requires a deep understanding of the complex structure and functioning. For the purpose of any construction, specialized skills, knowledge set is required for any site-specific information analysis. Any development or improvement in shoreline topography requires information on history of storm, winds, waves, water levels that affects the tide. Design specialists are required for constructing green shores, green buildings, and greenhouse. And now we come to the most important factor, the critical success factors for climate change adaptation. And the foremost is integration. Climate change adaptation should be integrated early into each project, from the first site and building concepts all the way through detailed design and project implementation. The next important factor is design innovation. A great example to this is Guanajuato, in Mexican Highland, a flood-prone area, the community decided to elevate the downtown area out of the floodplain, and the result is a beautiful heritage city at 2 levels. Similarly, Superstorm Sandy in New York City shows the importance to flood protection by building openings to underground transits. These examples show us that flood protection and sea level rise can fully be integrated into urban design and placemaking. Flood resilience and adaptation are fundamentals to these examples and result in a highly attractive urban design. Next, partnerships. Partnerships are the key for future, and one can reduce the accumulative cause and minimize the risk. Last but not the least, capacity building is equally important to further help to build communities' resilience. Now I call upon Charles to take on further. Thank you.
For the future and conclusion, because of the climate change, the temperature increased 1.4 centigrade every year in Victoria. And this situation sets off a chain reaction. For example, sea level keeps rising and snowpack becomes smaller year by year. We will have wetter winters, drier summers, higher sea levels, lower rivers, less skiing, and more complex and expensive infrastructure planning. Under these circumstances, many industries can be influenced, such as forestry, tourism, aquaculture, fisheries, agriculture, and energy production. The BC government has begun to take some measures to prevent disasters caused by climate change. $1.2 billion amount spent by federal and provincial governments since 2001 to mitigate mountain pine beetle damage. $9.5 billion estimated cost of replacing Fraser River decks to make them high enough to withstand expected sea level rise, and $255 million to $510 million cost of building decks or sea wall system to prevent flooding. Even though the climate change may bring some benefits of specific place or parts of different industries, it will still set off a chain reactions and more resources and money will be expended. For instance, the rising temperature and the longer growing seasons can bring benefits to agriculture, which means farmers in the Peace region may be able to grow crops more successfully. But this situation is bad for ski hills. Several closed earlier or didn't open it at all. Moreover, heat waves could pose a danger to the city's older residents. So anyway, it is important to prevent climate change. And thank you for watching. And here are some references